So if we're ever going to reach Mars, we need to not only overcome all of the massive technical and funding challenges and everything else that's going to come with sending Starship or whatever vessel eventually makes the trip all the way out to the Red Planet, but if we really want to colonize this place, that's going to be a challenge all unto itself, an immense one, perhaps the greatest challenge that the human species has ever embarked on. But one of the most annoying hurdles that we're going to have to clear at some point is all the damn naysayers who say that this stuff is impossible, especially those who are using either completely false or misleading science to back their arguments. And some time ago, I issued a video criticizing the work of one particular Elon hater out there. He then made me his hobby for a while, making a number of videos about me, not only about how I criticized him, but also about me coming after Jeff Bezos. Like I say, every man needs a hobby. I guess I was his, but I'm about to resurrect those old ghosts, sadly, by coming out with this again. But his channel has been growing very well. He's been doing an excellent job coming after Elon, which I don't have a problem with as long as your science is sound. And in this case, it just isn't. Okay guys, here to talk to you from my humble little quarters here in the Shetlands, or Shetland as they call it here locally. This used to be the officers' quarters apparently for a lieutenant or something like that in the RAF. Perfectly suitable for my needs, and now I'm going to be doing something that I've really tried extremely hard to avoid for quite some time, and that is to address some of the really serious misconceptions that are being peddled online by Elon haters who are trying to debunk the concepts that are being put forward, and in this particular case, in situ refilling, and of course he's copying what Elon said in that regard, probably I would say sarcastically. The individual involved here is CSS, or Common Sense Skeptic. Again, somebody that I chose to leave alone for a considerable period of time after I criticized him before. He responded not really by attacking my science, but mostly by attacking me personally and kind of my goofiness, and also saying that I'm not really an astronaut. Oh, really? Really? So anyway, we're going to be looking into this. It is a two-part episode. The first is 25 minutes of droning chemistry and mathematical formulas. I'm not sure how much of this is intended to be used for educational purposes and how much of it is just trying to demonstrate how smart and educated this guy is, and so therefore to make the case that he is indeed right. And by the way, the point that he's trying to make here is that the whole concept of using ISRU to create methane and to create methalox rather on Mars is laughably impossible. I believe I quoted him directly there. And by the way, NASA is also trying to do this as well. They also plan to do this. So apparently what they're trying to do is also laughably impossible. But instead of doing that, we're going to quickly review the 25-minute video, because really there's a whole lot of style and not a lot of substance in that first 25 minutes. A lot of chemical formulas, a lot of in-depth description, and also a lot of things that really have no application to the topic at hand before we really get to the meat of his argument in part two. Okay, so I'm resuming this recording during the day. Unfortunately, last night the weather was really violent. The wind was lashing against those windows, rain, etc. Kind of made it to where recording was a little bit more difficult. Weather is still pretty intense, but more importantly, this 25-minute video put me into a deep coma as I was trying to review it. So anyway, just kind of showing it to you at very, very fast speed at the moment, but it goes into, a very in-depth description of the process of converting carbon and oxygen and hydrogen, all of those into methane with the Sabatier process. Sabatier, some people have told me is pronounced. I've heard it pronounced all kinds of ways. In any event, this is what Elon says is going to be necessary in order to be able to create methane on Mars. You pull up CO2 from the atmosphere and you use water ice in order to get your hydrogen and, of course, the carbon from the CO2. And so what he's saying is that it's the process, first of all, gets into that. I'm going to hit just the high points because really, I'll tell you, he hit a lot of stuff that you don't even talk about. He goes into very, very deep detail on the process necessary, energy required, some of the basics on energy required, not really getting to his point yet. And also, of course, he says that the Sabatier process is not properly described by Elon, that there is actually other steps to the process, which is actually true. However, this is something that's already been identified. The University of California is already working on a process to make methane, make the Sabatier process far more efficient and not requiring as many steps as this guy's talking about. He also talks about the solar panel issues, loves that, and so he takes some of the Tesla solar panels as an example of what we're going to use on Mars. He knows damn well that we're not going to be using technology that primitive. We'll be using far more efficient solar panels than what is used by SpaceX at the moment for their consumers. There's way more efficient solar panels. Actually, the solar arrays that were deployed on the ISS recently are way more efficient than that. So that's another problem. And like I say, just go on and on and on. Skip. Oh yeah, he starts talking about on-orbit refueling, LEO refueling, which, by the way, is not really what we're talking about here with in-situ refueling. Wastes a lot of time criticizing other things. He also talks about what his entire argument, this you need to know, though. His entire argument is based on the concept of a single launch configuration or a single mission plan to Mars that involves human beings staying on the surface of Mars for 18 months. So all of his mathematics is based around the idea that humans are only going to have 18 months to manufacture the necessary methane. And this, of course, is completely flawed from the get-go. Anybody who's going to send a mission to Mars is going to send automated factories and drilling machines, etc., processors, in order to manufacture the methane long before the astronauts even arrive. There's no sort of dramatic race that astronauts are going to have to be engaged in to create the methane in time. You can do all of this ahead of time, and I would assume this guy knows this. He just doesn't tell you. And he talks about Starship and how much it's carrying. He talks about the Martian atmosphere and how thin it is, and all this is true, by the way. I actually believe that relying exclusively on extracting carbon dioxide from the Martian atmosphere is kind of a flawed plan, and it's not just Elon's plan, it's many people's plan. I mean, we got the Moxie on the surface of Mars right now making oxygen out of the CO2, and I also criticize that. I think there's better ways to make oxygen on Mars than trying to utilize an atmosphere that's less than 1% as dense. But this is a problem with the overall plan, not a problem with Elon himself, but that's where the focus is, because he wants to, convince everybody that this whole damn thing is a scam, although it, bears a lot of resemblance to what NASA's planning to do there too. So I guess they're trying to scam us. Is that what you're saying? And he also talks about The Martian and how inaccurate that movie was, and I've discussed that as well. I don't know what the hell that has to do with the topic, but hey, okay, let's go ahead and skip over. I mean, it's 25 minutes of this stuff, and so little of it actually has anything to do with the topic. Okay, so yeah, again, on and on and on and on and on about how thin the atmosphere is, therefore how much of the atmosphere you're going to have to gather in order to produce the necessary carbon, that, one carbon atom in CH4 in order to make methane. I know this just may sound like that I'm droning on, but you almost have no damn choice with this. So by the time you get to the end of all, it discusses Moxie, of course, and the challenges. Well, I mean, it's been very successful, but then it doesn't make a whole lot of oxygen. Also talks about silly industrial blowers, industrial machines that somebody would buy at Home Depot as maybe something that you would use to extract the necessary CO2. I don't even know why he discusses that. And then eventually, we get to the end, to the intermission at the end of 25 grueling minutes before you finally get to the meat of the argument. And here we go. So let's go ahead and find out what the common sense skeptic is going to teach us about making methane on Mars. And by the way, I could very well get copyright claimed on this, but hope you don't.
Before the break, we were discussing the possible capture methods for Mars's atmospheric carbon dioxide.
Right, so this is the machine he finally gets to. After talking about industrial machines that you'd buy from Home Depot first, and how much CO2 you're going to need.
Have to somehow store until it can be refined and processed.
Somehow store. I mean, we store liquid gases all the time.
Is 33.71 kilomoles of the gas. On Earth, at room temperature of 21 degrees Celsius, with atmospheric pressure of 1,013 millibar, 33.71 kilomoles of uncompressed carbon dioxide wants to expand to 807.9 cubic meters. With a different online calculator located at chemicool.com, we can see how gases would behave in a Martian atmosphere given the number of kilomoles. This is the ideal gas law formula. PV equals N over T. Pressure times volume equals N, the number of moles worth of a gas, times R, the ideal gas constant value of 8.3145, times the temperature in Kelvin. This online ideal gas law calculator lets you input values using different metrics for volume, pressure, and temperature, and does the conversions for you in order to find whatever value you are missing. In this case, we're looking for volume. On Mars, where temperature averages minus 60 degrees Celsius, with atmospheric pressure...
I don't even know why the hell we're talking about this. Why does the volume of carbon dioxide on Mars even matter to this discussion?
Or approximately the value of 40 Olympic-sized swimming pools.
Okay, so that's how much space it would occupy.
There would need to be a system in place to regulate both the temperature of the gas and the pressure.
No, Sherlock. Of course you would need that.
Splitting those carbon dioxide molecules gives us carbon atoms and twice as many oxygen atoms. To create methane from this, the two oxygen atoms...
All right, we discussed a lot of this already in the first part as to what the process involves. And yes, we know there's very little, the atmosphere is so thin, not a lot of resource.
Provide that raw resource to this process. Let's start by addressing the volume of water that scientists think, keyword think, is on Mars.
And that's true. We don't know for sure how much water is on Mars.
We know, using best practice, that on Earth we have somewhere in the neighborhood of 1,386,000,000 cubic kilometers of water. On Mars, scientists think there's about 5 billion cubic kilometers of water.
Okay, hold on. Now, this is something, once again, he loves to do these kinds of graphics to demonstrate just, look at that tiny bit of water that's on Mars. Oh my God, there's hardly anything there. 5 million cubic kilometers, without taking into account that there's enough water on our planet, not only to serve all of our needs here, but also for us to have had massive naval battles and, huge expeditions of exploration in the past. I mean, the amount of water we have on Earth is utterly insane. And the fact that we actually have as much water as he's picturing here, but he's doing it in such a way to really try to make it look like that there's almost no water on Mars, is utterly absurd. According to most scientists, experts, in terms of how much water we think is on Mars in frozen form, if all of that were melted, it would actually be enough to cover the entire surface of the planet to a depth of several feet. There is a lot of water on Mars, more than enough for our purposes for the foreseeable future. But okay, let's keep going.
Of water ice on or near the Martian surface. These 3D spheres represent, to scale, the water estimate of each planet, the sphere radius marked in kilometers. Maybe there's more water ice to be found, maybe less, but there is no liquid water on Mars.
Bullshit. There absolutely could be liquid water on Mars. There are so many other types of elements, including perchlorates and other things that we've talked about that create problems with water. But subsurface, it has not only been theorized. Many people really believe that because of the different elements that are also present in Martian water, it changes the freezing point dramatically. And so there could very well be liquid water beneath the surface of Mars. It's been modeled many times. And also, we've seen evidence of water erupting from the surface of the planet and streaming down the sides of the canyon walls of the Valles Marineris, for example. Now, we don't know for sure if that's what it is, and we don't know for sure that there is liquid water subsurface on Mars. But to say that there is absolutely no liquid water on Mars, completely unscientific. All right.
The lack of atmospheric pressure would cause liquid water on the surface to evaporate instantly. So this resource may have to be mined and transported as ice. That ice would likely be contaminated with extremely fine toxic dust and perchlorate salt. So the ice would have to be melted down into water and then distilled before it could be used in any production process.
True.
Certainly possible to do, but it would require more equipment, and that equipment, again, requires energy to run. Water will actually...
Again, not necessarily true. Now, true, distilling the water is going to require some of this, but also, as I've mentioned in a number of my videos, there are many types of earthborne bacteria that are capable of eating perchlorates and producing oxygen as a byproduct. And this is something we're almost certainly going to be taking to Mars. So the perchlorates that contaminate the Martian water can actually be used as a resource, as I say, as those bacteria break it down and destroy and eliminate the perchlorates, they can also produce oxygen for our use, and that requires no energy whatsoever. But yes, you're going to need to distill other undesirable elements out of the Martian water, so part of what he just said is true.
Actually provide two elements for the propellant synthesis: hydrogen for the methane and oxygen for the LOX tank. Water is H2O, with oxygen weighing 16 atomic units and hydrogen weighing only 1.
Why do we need the basic chemistry lesson?
Oxygen accounts for 89% of the mass per volume, and while the oxygen is required by the ship, it's the hydrogen we need to make methane with.
Right.
4 hydrogen per carbon atom, making up 25% of the methane mass by volume, and we need to create 534 kilograms of methane daily. But hydrogen only accounts for 2 of the 18 atomic units in the water molecule. Oxygen accounts for the other 16. So a quarter of the methane harvest quota, 534 kilograms, is 133.5 kilograms.
It's almost he's like in a class. He has to show his proof here. I'm gonna show the professor exactly how I came to these figures.
The hydrogen that they need. 1.2 tons of water might not sound like a lot. After all, it's less than 2 of these totes worth. In terms of pickup trucks, that equates to less than 3 half-ton payloads.
Are you trying to advertise for the Ford F-150?
And something, or someone, is going to have to move the water or ice to the processing plant.
Again, bullshit. Here's the deal, and he's going to go into a lot of depth here in a minute talking about where the water actually is. And this is completely untrue, at least as far as we know. Once again, he is right. We don't absolutely absolutely know where the water is on Mars. However, we do know that there is many substantial reservoirs of water ice subsurface on Mars in places that are not at the damn poles. As a matter of fact, Elon went to NASA to ask where large reservoirs of water ice just beneath the surface are probably located in order to pick some landing sites, and these are the locations that NASA gave him, and it's nowhere near the poles. So the whole notion that you're going to have to truck water ice all the way from the poles is completely incorrect. It's completely... I can't even believe he's saying this. And once again, it seems to me that he's just trying to take advantage of uninformed people. I can't imagine that he doesn't know this. Maybe he doesn't, but I really think that instead he's just trying to, take advantage of the fact that most people just don't know this stuff. And once again, not cool, dude. I mean, you can criticize Elon, just get your science a little better.
It needs to be said that there are seasonal pockets of surface ice on Mars, but those locations are generally at the poles of the planet, which would be the exact wrong landing site.
Okay, this water map. Look at this water map. Have a look at the date. 2001 Mars Odyssey Gamma Ray Spectrometer. This stuff is over 2 decades out of date. And this is what he's showing us. See, no water on Mars. You want to see another map? How about this one? Look at all that water ice that's located in the Valles Marineris right on the damn equator.
With solar power. As with Earth, Mars has a similar planetary tilt, which gives the planet seasons much like Earth. So there are periods over the course of a year where those poles would get very little sunlight over the course of a day. And mining the ice might prove a little trickier than people think as well. The most efficient way, of course, would be using machinery such as drilling rigs, but this machinery would have to be powered by high-voltage electricity and suited to the conditions on the Martian surface.
Yeah.
Since the visible surface ice is located at the poles...
Visible surface ice, you're right.
Having to dig down and...
He's actually right there. Visible surface ice is at the poles for the most part. But we're not talking about that. We have loads of evidence to indicate that there is an incredible amount of ice just subsurface. As a matter of fact, some of the probes we have on the surface have dug just a little bit into the regolith and found ice right there. And once again, not only is Elon looking to exploit this, also NASA is. I mean, this guy is not only saying that Elon is full of he's also saying that, NASA is too.
In the hopes of hitting a pocket of solid ice, to use something like a Rodwell system as shown here. This sends hot water down one pipe into a pocket of ice, melts the Martian ice around it, and pumps back colder liquid water. Okay. This paradigm requires a drilling rig, a pump assembly that works under Martian gravity and atmospheric pressure, and a heating source for the water, all of which will also have to run on electricity. We know
nobody's saying this is going to be easy.
The temperature of 1 liter, 1 kilogram of water by 1 degree. Every day, they'll need to harvest 1,201.5 kilograms of water.
Once again, every day they're going to have to do this. Well, that's if they have only 18 months at their disposal, if they're stupid enough to only start the process when they arrive. He's talking as if astronauts are going to have to be, frantically doing this to get the methane they need. Obviously, any logical and intelligent mission is going to do all of this stuff beforehand with robots before we even risk human beings.
But how much would the water ice need to be heated before it could be pumped to the surface? Special thanks going out to Goodsa1 and Karthik S, 2 of our Twitter followers, for helping out with that question, which was not the easiest to answer, due to the fact that water on Mars has a triple point, right at 0 degrees Celsius, where solid, liquid, and gaseous water are all equally stable. To keep it as a liquid, the water would have to be warmed higher than 0 degrees and kept under pressure to get it firmly into the green patch of this phase diagram. Call it 10 kilopascals of pressure and 15 degrees.
It's actually useful information right there. It's nice to know those details.
Method, according to another online calculator at omnicalculator.com, just to warm the ice up from minus 60 Celsius to 15 degrees Celsius.
Okay, where the hell did you get that figure from? Why is the ice going to be minus 60 degrees Celsius? There are many places on the surface of Mars where the temperature is much, 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 much warmer than minus 60 degrees Celsius. So, I mean, obviously, ice tends to be 0 degrees Celsius, the freezing point of water. And in some places, actually, it gets much warmer than that on Mars. You get to the point where water would actually melt if it were on the surface. The reason, of course, there is no surface water is because of atmospheric pressure, not always because of temperature. Yeah, let's keep going.
Would require 628,781 kilojoules or 175 kilowatt hours.
Yep, lots and lots and lots of power if it's minus 60 degrees Celsius, which it isn't. So given the extreme length of CSS's presentation, it's necessary to divide my reaction video into 2 separate parts as well, unfortunately. I'm very sorry about that, but it is necessary. And by the way, Mr. Skeptic, if you are watching this right now, I'm about to give you a very good reason not to copyright claim this in the next episode. Oh, and by the way, if you guys want to tune in, you're about to find out something we really need to make sure Kim Jong-un doesn't hear about: how to make a nuclear weapon several times more powerful than the one that destroyed Hiroshima using methane. Hit that like, smash that subscribe, and as always, stay angry about space.